let's look at solving this quadratic equation. Now, we're talking about the zero factor theorem, and you may even want to write that down like an abbreviation, like ZFT. And that tells you exactly what to do. What does the Z stand for? Zero, so I have to have it equal to 0. Is it equal to 0?
No.
How do I get it equal to 0?
Minus 16.
Subtract the...
No.
Subtract the 16.
Oh, that was cool.
So then what do I have?
3x squared plus 2x minus 16 equals 0.
3x squared plus 2x minus 16 is equal to 0.
That's cool.
Do y'all agree? Now you've got to factor this. Now, this is a trinomial. Is there a common factor to take out of everybody? No. So I expect it to factor my two sets of parentheses like this, my two binomial factors. Now, we were talking about this yesterday, writing out all of your factors that you have. Okay? So for the factors of 3, it would be 1 and 3. What about the factors of 16? 1 and 16, 2 and 8 are 4 and 4. But I also said you watch for those factor pairs that have common factors, right? 4 and 4 have a common factor of what?
2.
No.
4.
Common factor of 4. Does 4 go into 2?
No.
So you can't use 4 and 4. Now, 2 and 8 have a common factor of what?
2.
Does 2 go into 2?
Yes.
Then you should use that combination when you break this guy down. Okay. Now, since 3 is a prime number, you know there's only one way to break down 3x squared. What is that? 3x and x.
Can we put x and 3x?
Sure.
It doesn't matter?
No, it doesn't matter. You put x and 3x or 3x and x, it's going to be the same. What do you know about your signs?
Plus negative.
Let me do this in pencil just to make sure we don't mess up. So you say positive and a negative, right? Now, excuse me. If I'm going to use the 2 and the 8, let's see what happens. If I put the 2 here and the 8 here, does that work out? That gives me a plus 2x but a minus 24. That's nowhere close, is it? What if I swap these guys? If I put the 8 here and the 2 here, does that work out?
Yeah.
That gives me plus 8 and minus 6. Is plus 8 minus 6 this guy?
Yes.
All right. So we have the right combination, even the right combination of signs too. So that's plus 8 minus 2. Now notice, I started with an equation, so every step along the way will also be an equation. Okay? Now, how do I finish this?
So write it down 3x plus 8.
Well, if I do this guy first, if I have x minus 2 equals 0, that means x equals what?
X equals 2.
X equals 2. Now do it for the other guy right here. See if you can do this in your head. What are the steps you would take to get x by itself if this guy were equal to 0? What would you do first?
Minus the 8.
You would subtract the 8, and then you would
Divided by 3.
divide by 3. Now, if you're not sure about that, you don't really like doing that, then you can come over here to the side and take 3x plus 8 equal to 0, minus 8 on both sides. So 3x equals negative 8, and then divide both sides by 3. But that seems like an awful lot of work when I can just take care of this in my head. It's not a lot of stuff to keep up with. Okay. So what do you guys think about that one?
So basically, you're just sort of putting reciprocal.
No.
Not the reciprocal, but just the opposite.
Well, it's as though you're solving for, you're solving it equal to 0, so you would add to the other side. Of course, that's the opposite of this, but negative 8/3 is not the opposite of that. You had to subtract the 8 and then divide by 3. And so what that does is that leads us into what should be a really simple problem. If I take 9x minus...
Sorry. So this basically, that's the answer up there? I mean, it's not, I mean, there's nothing else, I mean, it's.
No, it's
not a true
solved.
statement, or-
You found what the x's should equal. If you plug either one of these into the original, it's going to work out. Now, I'm not always going to show the check, but you should be able to plug those in individually.
That's why you're saying they're not always going to be the same numbers for x.
What? I'm saying that x equals negative 8/3 is the solution. If I plug in negative 8/3 here and here, all of this is going to equal 16. Or if I replace the x's with 2, if I plug in the 2 here and here, it's going to give me 16.
Oh, I just don't think I asked it right. Got it.
Now, the question that I have here now is something that should only take you about 15 seconds to do. If it takes you longer than that, then you're doing something wrong.
X equals 25 over 9.
You guys are just jumping right up there to it. Notice this guy's already equal to 0, right? And it's already factored. So that means from here, we can just say that x equals, you would add the 25, and then you're divided by 9, right?
4.
On the other factor,
X equals 5 over 2.
it's not 5 over 14.
-5.
You have to subtract the 5 first, right? And then you divide by 14. If you take this guy and multiply it out and get some huge polynomial, you're only going to have to factor it back. But this guy's already factored, so why would you make it more difficult than it is? I've done all the work for you. It equals 0, and it's factored. Expect to see something like this on your test. Well, I've already done the work for you. You just have to be able to recognize it. Questions about that one?
And you got 25 over 9 because you added 25.
If you set
Oh,
this,
nine less. So
if
nine
you were to
makes-
take this guy and set it equal to 0 and solve it out, solve for x, you're going to get 25 over 9. But these are easier to take care of in our head because it doesn't equal anything else except 0. So it's not like it's a 9, okay, I got to add 25 to 9, and then, no, it's, you add 25, divide by 9, and you're done.
So this we have to write out as 9x minus 25 equals 0, and then.
Right.
Okay.
Right. Let's try this guy. 2x squared plus 8x minus 90 equals 0. Say again? Well, of course I'm going to need a factor, but it's the zero factor theorem that I'm using, right? Z for 0, does this equal 0? All right, then we can move on to the next step, which is factor. How do I factor this?
And just take the 2 out.
It's not really a question of can I take the 2 out, but I should take the 2 out. Because the process isn't take out a common factor if you want to do it. It's if there's a common factor, you take it out. So what's the common factor here?
2x.
2, not 2x. Because x doesn't go into 90.
Oh,
If I factor out the 2, what do I have? X squared
it's 4x
plus 4x minus
45.
45, and this is still equal to 0. It's, you start with an equation. Every step along the way is an equation. Okay. I keep factoring this guy. How do you factor x squared plus 4x minus 45? It's a trinomial, so I expect it to factor as 2 binomial factors. So what do you get?
X plus
X plus 9 and then
X minus 5.
x minus 5. So let's see what solutions I get here. From the x minus 5, that means that x equals what?
X plus 5.
5.
Now don't say x plus 5.
I mean, X equals 5.
X equals 5. And what about here from x plus 9?
X negative 9.
X equals negative 9. What about the 2?
Multiplies.
Does 2 equal 0?
No.
Yes.
2 equals 0?
I don't know.
You
I've got
multiply?
2 kids. That is not the same as having 0 kids.
Don't you multiply 2 times negative 9? No?
No?
What do you do with it?
You multiply.
No. What we were doing before is we set each factor equal to 0. Right? When will x minus 5 equal 0? What makes x minus 5 equal to 0? x equals positive 5. For what value of x will x plus 9 equal 0?
Minus 9.
Negative 9. When does 2 equal 0?
Minus-
Never. So
Oh, I mean, right there. now.
2 is a constant. 2, that factor, the value of that factor doesn't change. 2 is always 2, right? So can 2 equal 0?
No.
No. Can x plus 9 ever equal 0? Yeah, it can.
Yes.
When x equals negative 9. Because it has a component that can change its value. It's a variable, x. Now you may say, oh, shouldn't I have multiplied these guys by 2? No. If you had not taken out that common factor of 2, you probably would have factored it and would have looked something like this. I don't know, 2x plus 18 times x minus 5. That would have worked to give you the original guy up here. But if this is equal to 0 and you solve this, what do you get here? 5. What do you get here? Negative 18 over 2, which equals what? It's still negative 9, right? That's why I want you to take out the common factor. And what you saw here is that if this common factor is a constant, he's never going to equal 0. How many solutions do I have here? 2. What was the degree of my polynomial? Had a degree of 2. And that's your clue to help you figure out how many solutions you expect to have for this equation.
So what do we do with the 2? We just leave
Nothing. It does not contribute to a solution.
So the answer is just x equals negative 9 and x equals 5.
Right.
That's it.
These are your two solutions. That's it.